Okay, here we go. So I want to get through a lot today. This is going to be intense, but it'll be no problem. We'll get through it in a hurry in this group. So I want all distractions away, please. Everything, phones away, all that stuff. So we're going to close up with a little bit of the algebra stuff we were talking about yesterday. Where'd Emma go?
I don't know.
Her mom just excused. Oh, that's probably what it's for.
Yeah.
Yeah, probably. I think she's headed back down to the office.
Okay.
So a couple of these that we started yesterday. So how do we do this algebraically, right? So algebraically, all we would do is we want to know if I take the expression on the left side of the equation and I expand it out, put it into simplified or standard form. It's going to be a quadratic function, isn't it, right? Quadratic expression. What's going to be the coefficient of t? Normally it'd be x, this time it's a t, right? So if I do all that stuff, t minus 3 squared plus 41, I'm just going to simplify using PEMDAS. So the first thing I would do is exponent, right? Have to square that out. What does that work out to be if I expand out t minus 3 squared? So it's t squared, so it's an a plus b quantity squared issue, isn't it? So I'm going to get a squared plus 2ab. Well, a is t and b is negative 3, right? So what's a times b? Negative 3t times 2?
Negative 6.
And then negative 3 squared? 9. So when we combine like terms, we just get t squared minus 6t plus 50, right? So what's our coefficient of t? Right? Make sense? Negative 6. Okay? Okay, there is a shortcut. This is one where we're trying to see, we want to fill in a blank so we get equivalent expressions. We want to know what has to go there to make the left expression equal the right expression, right? So this is a good candidate for that trick we talked about yesterday, where we just pick a random value for the variable. Yes, sir.
Are these still on
Yeah, they are. So this is a good candidate for the one where we just pick a random value for t and see what value of the unknown we'd have to put there to make it work, right? Makes it a lot easier, doesn't it? So if we call that x, and I plug in 1 for t, I'm just going to get negative 2 squared plus 41, which is 45, right? On this side, we're going to get 1 squared plus whatever you want to call it, x times 1 plus 50. And when I clean that up, I just get 45 equals 51 plus x. So to isolate x, I get negative 6. Either way, right? So once again, it's when you're doing stuff like this where you've got left expression and right expression that have to be the same, and I'm filling in a blank there. Really good candidate for doing that trick we'll talk about, okay? Substitution trick. So what about this one? So we can do the algebra. This is just a property of exponent situation, isn't it? Right? So if I've got, I'm taking a product of 3 times p to the power 2. What do I do there? What is 3p quantity squared?
3 squared plus, or 3 squared times p squared?
3 squared times p squared. Good, so we're going to get 2 times 9p squared minus 7p squared equals, call it whatever, let's call it a. Not that color. A times p squared. Okay, so a times p squared. Well, on the left side, what's 2 times 9p squared?
18.
Minus 7p squared is what? So if 11p squared equals ap squared, what's a? 11, right? Okay. We could do this with our trick too, couldn't we? We just set p equal to 1. We could figure out what's the value that has to fit in there to make it work. So I would just get 2 times 3 squared minus 7 times 1 squared equals x times 1 squared. And I end up with 11 equals x. And so the substitution trick would work great there too. Okay, what about this guy? So what value, when placed in the box, makes an equation that is true for all values of x? So here's one where, if we do the algebra, you know, we don't have to, we can be smart about this. We don't have to do so much work on this. We can just kind of think about what would happen if we did this. If I were to simplify everything on the left, and I'm going to call that A, because that's what we're solving for us. Whenever it gives you a box like that, you know, call it the unknown. It makes it easier to think about. I don't want to use x, though, because I've already got an x in here, right? I have to use something else. So we're solving for A. If I were to multiply out A times x minus 7 times x plus 11, think how you would do that. I multiply in pairs, right? So we'd maybe FOIL out all this stuff first, right? Expand all this out. Well, if I distribute the x, I'm going to get x squared plus 11x, distribute the negative 7. Ultimately, I'm just going to get x squared plus a bunch of other junk, right? When I do all that stuff in there. And if I distribute the a to each of those terms, wouldn't you agree I'm just going to get ax squared plus some other junk, right? But the thing is, my quadratic term, my leading term in that polynomial is going to be ax squared, right? What about on the right side of the equation? Well, if I expand all that out, I'm going to have to get the same number of x squareds on both sides of the equation, right? The leading terms, everything has to be equal if it's an equation, right? So if we look at the other side, if I expand out x plus 2 squared, I'm going to get x squared plus 4x plus 4, but we don't even really care about that stuff. I just know I'm getting an x squared in there. And when I distribute the 4 over everything, when all the dust settles, I'm just going to get 4x squared plus a bunch of other garbage, right? If the two polynomials are equal, though, doesn't that mean that A has to equal 4, right? Everything, they have to be equal polynomials. So all I really need to do is consider the leading term there. Okay? Saves a little time. So the other thing you could do is the trick, right? There's another classic example where it would be great. If I want to figure out what the value of A is, so the left expression is equal to the right expression, right? They're equivalent expressions. Let x equal 1 and see what you get. If x is 1, I get A times negative 6 times 12. On the other side, I'm going to get 4 times 3 squared minus 324. So I get negative 72A on the left, and all that. If I multiply all that out, I'm going to get 36 minus 324, which is negative 288. Divide each side by negative 72, and the calculator tells me it's 4. Okay. Either way, I get 4. And that trick, it's amazing how much you can use, especially on these kinds of problems. It just is really valuable. Okay, so we won't even do this one. What would we do? Yeah, I'd have to simplify first, right? Distribute, collect like terms, and then isolate x, right? Push the x's to one side where I get a positive number of them. Isolate x, and we're done. I'm not going to go through it. You guys can do that. Okay, here's one. We're pretty good at these, right? We've done a lot of this stuff. So what are the 2 steps to get that x by itself? Subtract 12. Okay, so I get negative 3x is greater than 15. Do you agree? Now what? Okay, there's the trick. What they're bargaining on is you're not going to remember that if I divide or multiply both sides of an inequality by a negative, that means I've got to flip that inequality around, right? So then I end up with x is less than negative 5. Okay? Okay, what about this kind of thing? So let's talk about these. Likely to get some of these on there too. They sound hard, they look hard because they got all kinds of variables in them, but it's no big deal. When they ask you to solve an equation for h in terms of r and v, all that means is you should expect to get R's and V's in your answer. That's all that means. If we're solving for something in terms of R and V, then just expect you're going to get R's and V's on the other side of the equation, right? So all this is then is we're just trying to isolate H, isn't it? Solve for H means we're going to isolate H. So what are the things I'd have to do to get that H by itself? I'm just reversing PEMDAS, right? When I isolate, I go backwards, bottom to top. Any addition or subtraction to do?
No.
No. Any multiplication or division? Lots of it. That's really all there is, isn't it? Right? So how do I undo multiplying by 1/3?
Divide by 3.
Hold on.
Multiply by 3.
Multiply by 3. Right, so the 1/3 cancels with the 3, right? And then I end up with 3v equals pi r squared h. You gotta get the h by itself. How do I undo multiplying by pi r squared? Divide by pi r squared. There you go. Right, so then we end up with h equals 3v over pi r squared. That's it. Okay? So how would we do this one, number 8? It says for the given equation, find the value of t when m equals -1/2. Plug in -1/2, absolutely, right? Plug that in, and what's that going to give us? So if I plug that in, I get t divided by -1/2 equals 40, right? So there's really, there's two ways we could do this pretty easily, equally good. How do I undo dividing by -1/2? I multiply by -1/2, right? So one thing I could do is this. Right, so the -1/2's cancel, and I get t equals, what's 40 times -1/2? Or I could simplify this, dividing by a fraction. What do I always do if I divide by a fraction? Multiply by the reciprocal, flip and multiply. So what's the reciprocal of -1/2? -2/1, or just -2. Right, so we can rewrite this as -2t equals 40, divide both sides by -2. Either way, I'm getting -20, right? Okay, and then we're not going to do this one, but what would I do? For the given equation, find the value of c when f equals 92. Plug in 92, isolate c. So what are the steps in order to get c by itself? Subtract 32, get a number, and then
Divide by 9.
okay, but how do I, instead of dividing by 9/5, multiply by 5/9, right? Okay, good. All right, solving quadratic equations. So it wants us to, we're going to practice, we've done a ton of this, easy stuff for us, right? The good news is, typically on tests like this, at this level, you're mostly going to get quadratic equations to solve, and that's what we're the best at. Right? So that's good news. So 8x squared minus 72 equals 0. So on these, it's a quadratic equation, right? The biggest power of x is 2. So on these, we're always just going to go back and think unit 2. We want to be strategic about this, right? So what's our strategy here to solve for x? We want to make it as easy as possible. Add 72, and then what? Divide by 8, and then what? Square root. Good, we're isolating x, because we can point to a single x, right? There's a single x in the equation, no other terms with x's in them, so we'll just isolate that x. Add 72, get 8x squared equals 72, divide by 8, I get x squared equals 9. So what do I get then? Positive or negative, right? Now, how many solutions should we expect to get? 2, because it's a second degree polynomial, right? So if we just got 1 back, we'd have to really pause and look at that and say, okay, is that really a double root? Okay, but this one's not, right? We get x, if I square root both sides, I get x equals plus or minus 3, okay? The only way I'd end up getting a single answer is if I had something like x squared equals 0, right? Then I would get just x equals plus or minus square root of 0. Well, that's just plus or minus 0. That's just 0. Same thing. Okay? Okay, what about this guy?
Move that x to the left side.
Okay, good. I gotta put everything, I gotta set it equal to 0, don't I? Put it in standard form. So I get x squared plus 10x, well, it's not plus 10x, plus 13x plus 30 equals 0, right? I gotta get that 0 over there, so it's in standard form. Now we'll just pick the easiest method. So I could always use quadratic formula, but can I make it easier? Can I find magic numbers?
10 and 3.
Right, 10 and 3, there we go. So x plus 10 times x plus 3, and what are my solutions going to be? Remember, the magic numbers are not the solutions. That just helps me factor.
Oh, negative 10 and negative 3.
Yeah. Right, so I've got to, once I get it factored to find the solutions, I've got to use the zero product property. Find the zeros of the factors, right? Okay? Good. And then finally we get one down here where we're solving a quadratic equation. Now look at all the results. So none of those are easy, right? What technique do you think you're probably going to use here? Quadratic formula, right? It's not going to factor, is it? Okay. So what are our values of A, B, and C? 1, 6, 15. Okay, good. So remind me real quick, what's our quadratic formula? So if I start off with something in the form ax squared plus bx plus c equals 0, what's the quadratic formula tell us?
Square root a squared minus 4ac divided by 2a.
There you go, beautiful. Okay, so if we plug in our numbers then, we're going to get x equals negative b, so that's negative 6, right? Plus or minus the square root of b squared, that's 36, minus 4 times 1 is 4 times c is 60. So 36 minus 60, all divided by 2 times 1 is 2. Okay, so when we think about the quadratic formula, in order to make the denominator easier to say, right, we always make it a common denominator, but we want to split this thing apart into separate terms. So we're going to end up then with x equals negative 6 over 2 plus or minus. Now, what's all this stuff going to be? It's going to be negative. What is 36 minus 60?
Negative.
Okay, so all that stuff is going to end up being square root of negative 24. What's the negative do for us?
Imaginary.
Okay, so we know we're going to get an I from the negative, right? We know we're getting an I. What about the square root of 24? So we want to simplify that. Couples go out, singles stay in. We make a factor tree. 6. So what does 24 factor into?
6.
4 and 6? 4 breaks up into
2 and 2.
And the 6, we can break it up if we want to, but we can already tell, if we think about it, that it's not going to do us any good, right? I'm going to get a couple of 2s and single 2 and single 3. Couples go out, so we get a 2 outside, don't we?
For sure.
Oops, outside, not inside. Singles stay in, so 2 times 3, those are the singles. I get a 6 inside. Okay? And then I just simplify this, right? So I end up with negative 6 over 2 is -3. The 2's are going to cancel, so I get plus or minus the square root of 6 times I. So what number, or what is that? Looks like that's what, C? Oh, B, whoops. Yeah, B. There's no 2 there. Right, the I, they put the I out in front of the radical. That's fine. Doesn't make any difference. Okay, same thing. Everybody see that? Okay? Okay, what about stuff like this now? Equivalent equations have exactly the same solution set. They're giving you a really important clue here. Equivalent equations have exactly the same solution set. Mark yes or no to indicate whether each equation is equivalent to this equation. Okay? So now this is a little bit different. This time we're not talking about expressions being equivalent. We're talking about equations having the same solutions, right? How many solutions should we expect to get out of that equation? 2. Okay? So any of these equations down here, in order to be the same solution set, has to have how many solutions? 2. Well, right away, we can see that that one's going to be a no, isn't it? I mean, I guess we could...
Case closed.
Case closed? Okay, probably. And I guess we probably should do something first. We probably should just solve this thing. Let's do that. So if we solve this equation, it's an easy one. P squared plus 6p plus 9 equals 16. First step?
That's not right.
Which one is it?
16.
16. We got to get it equal to 0, right? So p squared plus 6p, what, minus 7 equals 0. Got to get a 0 there. Are there magic numbers?
7 -1.
P plus 7 times p minus 1 equals 0. So my solutions are
-7, +1.
right? Those are my 2 solutions. So this one's only got 1, doesn't it? Right? How about this one? Well, if I subtract 3, I just get 1. It's not both of them, so that's also no. What about the top one? Well, we don't know. We got some options though, right?
Yeah.
We could solve the top one and see if we get the same results. That's easy enough to do.
But didn't you say if it's in it's only the 2, it's gonna have 2 answers?
Right, but you know it's going to have 2, don't you? Right?
Yeah.
So p plus 3 squared equals 16. What are the 2 steps to get that to solve for p?
Square root.
Square root. So that's going to give us p plus 3 equals
Plus or minus.
plus or minus 4. Last step, subtract 3, and we're going to put it in front of the plus or minus, right? So we end up with p equals -3 plus or minus 4. So if we take the plus, what's -3 plus 4?
1.
Okay? What if we take the minus, -3 minus 4? What do you know? We get the same answers, right? But we could have even avoided that work if we want to by just knowing that we expect this one to have 2 answers. So we could have even just done this. We could have even just said, well, let's just try these and see if they work. If I plug -7 in there and I plug 1 in there, do they work? If I plug -7 in, I get -7 plus 3 is -4 squared is 16 equals 16. Check. It works. What about 1? 1 plus 3 is 4 squared equals 4 squared. Check. Right? So it has 2 solutions, and these are the 2 solutions that worked, and so we could even just try them and see if they work. Okay? Make sense? Okay? All right, we're getting there. So how about this one? These are good. I like these. Consider the equation x squared plus bx plus 4 equals 0, where b is just a real number, no i's. Right? Could be anything. It says find a value for b so that the equation has no real solutions. Okay, now what's weird about this? What makes people kind of nervous about this problem and makes them probably want to quit early on this one is that it's, how do you solve that if there's no number in front of the x? It's a b. Just solve it, right? What's going to happen if we were to solve this? The coefficient of x squared is 1, right? So a is 1, c is 4, and b is b, right? If we solve this thing using the quadratic formula, we have to, because we don't know what b is. We can't factor it, right? I would just get x equals -b plus or minus the square root of b squared minus 4 times 1 times 4 is 16, everybody agree? Okay, all divided by 2, okay? Now, we don't have to go any further than that, right? At this point, we can just be smart about this and think, okay, what's the only way I'm gonna get non-real solutions? Imaginary numbers. Now, how do we create imaginary numbers?
You have a negative in the fraction.
Negative in the radical, right? So everything in here would have to produce a negative number. All this wants is a value of b that's going to work. That's going to make this. It's going to make this thing fail to have real solutions. It's going to make the solutions imaginary. So give me an example.
2.
2. Great. 2 squared minus 16 is negative inside the radical. It works. Another one. 1. Another one. 3. 0. Negative 1. Right. All that stuff. So really, just anything that's between negative 4 and 4 is going to work, isn't it?
So do we have to put that as the answer?
No.
No. Okay.
It just says find a value, so you just pick a value. Okay. Question?
If it was, oh, never mind, I was,
Make sense?
right, yeah.
Okay. Okay, how about this one? Same kind of question. X plus 5, quantity squared plus k equals 0. Well, k is a real number. Find a value for k so that the equation has no real solutions. We'll just do the same thing, right? We're just going to try to solve for x and then pick a value of k that's going to make those solutions have i's in them, right? So they're not real. All right, so what would I do? If I want to solve for x, what's the first thing I would do?
Move k to the other side.
Subtract k from both sides, right? So I'd get x plus 5 squared equals negative k. What's next?
Radical.
Okay, square root. So I'm going to get x plus 5 equals, okay, but
Square root of
I always got to do what if I'm square rooting both sides of an equation?
Plus or minus.
Plus or minus the square root of negative k. So pick a value of k that's going to make that negative on a radical. 1. It's another one. Another one. Another one. It's getting boring, right?
All real numbers.
Well, not any real number. It's got to be positive, right? Negative 1 times a positive gives you a negative result, right? Couldn't be 0. Negative 0 is just 0. Right? Square root of 0 is 0. Has to be a positive number. So any value greater than 0. Okay? Okay, what about this? So very simple stuff. This is just this new topic sort of here. Write any expression equivalent to all this stuff combining all like terms. Write an expression equivalent to this where you've simplified it. All like terms are combined. Well, this is pretty simple stuff. What's the coefficient of this first quantity? What's out there? 1. So when I distribute it, it changes nothing. What's the coefficient here? 1. I distribute it, it changes nothing. What's the coefficient here?
Negative 1.
Negative 1. It does change stuff there, right? So when I distribute, I end up with 8x squared minus 4xy minus 5 plus 3x squared minus 22. Now I got to distribute the negative, so I get a negative 7xy plus 6, right? So all I've got to do is just add up like terms. Well, I've got some x squareds to add up, I've got some xy's to add up, and I've got some constants to add up, right? And if I do all that stuff, what do I get? How many x squareds do I have? 8 plus 3 is 11. Good, I get 11x squareds. How many xy's?
Negative 11. XY.
Yeah, negative 11 xy.
Negative 20.
And then, yeah, here I'm going to get negative 27 plus 6 is negative 21. Okay? Just more of the same. All I do is just distribute coefficients and add like terms. Okay, another one here. So this goes back, property of exponent stuff. this looks complicated, but no big deal. When I'm multiplying, I've got a coefficient, powers of x and powers of y in both quantities, right? We're multiplying how many things together here? Well, 1, 2, 3, 4, 5, 6 total. 6 factors being multiplied together. But I just multiply in pairs, and I can group those pairs or associate the pairs any way I want to when I'm multiplying. So why not group up the things that are easy to multiply together? Right? So for example, we could multiply the 10 times the negative 1/5. I could multiply the x cubed times the x, and I could multiply the y squared times the y to the 4th, right? And what do we get? What's 10 times, well, let's just write this all out. So what's 10 times negative 1/5? Same as 10 over 1 times negative 1/5. Negative 2. I get negative 10 over 5, which is negative 2. What's x cubed times x? X to the 4th. That's the same as an x to the 1, isn't it? Right, so we got an invisible 1 there. And then y squared times y to the 4th? There you go. Right? Okay, we're getting there. I think we just have 3 more pages and we're done. This page and 2 more. So this is a quick one. We're not going to do anything. Right? What would we do here, though? If we were going to multiply this out, this is so simple, right? This is just distributing. This is FOILing. I could just distribute the 3x, distribute the 4, and add like terms. Piece of cake, right? Okay, how is this different down here? Only difference is I'm multiplying 3 quantities instead of 2. So when I multiply, I always multiply in pairs. So what's my strategy down here?
Multiply 2 together, just multiply.
Yeah, good. I'm just going to multiply 2 together, get an answer, simplify that answer, and then multiply those together. Then distribute again and simplify. That's it. Okay, very simple. Okay. Okay, which expression is equivalent here? So here's one where we could do this a couple ways. So we could do this the long way, right? We could do this algebraically. I could take this top one, and I'm just going to simplify it, right? If I distribute and add like terms, don't I just get ax plus 9 minus 4x plus p? I just want to find all the ones that match that. I'm trying to find, well, actually only one of them does. We can cancel out a bunch though, can't we? That's not equal to that. That's not equal to that. If I distribute up here in this top one, if I distribute the 4, I get 4a minus 4x plus 9p. Those are different, right? So that one's not it. This is the one that works, right? If I distribute the x, I just get ax minus 4x plus 9 plus p. Those are the same, aren't they? Same terms. Order doesn't matter. We're adding, right? Adding and subtracting stuff. Okay. So that's one way to do it. The other way we could do it, I'm not going to go through the whole thing, but the other way we could do it is, what if we just said, I've got a's and x's in there, right? Okay, if I've got a's and x's and I'm just trying to find equivalent expressions, let's just let like a equal 2, x equal 3, and see what number I get there, and then whichever one gives me the same number is the answer, right? Okay? Same problem, isn't it? Down here we could do the same thing. We could either do it the long way, or we could just do the same thing. Let's let a equal 2, x equal 3, just randomly. Those are nothing special about those numbers. But if I do that, I'll get a number and see which number matches it up, right? Okay. What would happen if 2 of them gave me the same number down here? Then I would just, pick different numbers and see which one still works. Right? Okay? All right, this is probably our last page. Okay, so what about this one? Moving on to new topic. This topic's kind of more about models, about mathematical models. So here's math that actually represents something. So the height in meters, h is what represents the height in meters of a model rocket above the ground, is given t seconds after launch by all this stuff, right? So here's our function, h equals negative 5t squared plus 60t, right? Let me make this a little bigger. Okay. Here it's telling me t is greater than or equal to 0 and less than or equal to 12. Is that the range or the domain? This one right here. Okay. What's the input variable here? Am I inputting t's or h's? Are you sure? I'm inputting t's, aren't I? All right, inputting t's to calculate h, right? So really, I could write this thing if I wanted to. It would probably be better to rewrite this as, using function notation, h of t equals negative 5t squared plus 60t. Everybody see that? So I'm inputting t's and I'm outputting h's. So that means that this has to be the domain, doesn't it? Right, this stuff right here. Those are the input values. What does this tell me? H has to be greater than or equal to 0 and less than or equal to 180. What's that? That's the range, because those are the possible output values, right? Domain is all the set of possible input values. H is the set of all the possible output values. So this part right there is the range. It says choose all of the statements below that are true. Well, let's just check these things. It's easy to do. H of 5 equals 175. Well, let's find out. H of 5, every place I have a t, I'm just going to plug in a 5, right? What's that give me? 5 squared is 25 times negative 5. That's negative 125 plus 60 times 5 is 300. So sure enough, I get 175. So I plug a 5 in and I get a 175 out. So first statement, true or false? True. True. Right? Second statement, the height of the rocket is 0 meters after 12 seconds from the launch. What do you think, based on our domain, what do you think?
0. No.
It starts at 0 is when the rocket's launched, and 12 seconds must be, what's it going to do? What kind of equation is that? They're t's instead of x's. I mean, t is time, sure, but if I just think, is it linear? What is that? What's the biggest power of x, or t in this case? 2. So what do we call that? No. That's quadratic, isn't it? Isn't that quadratic, right? Isn't a quadratic equation? That's just one where we end up with x squares. Instead of linear, we just have x's. Quadratic, we have x squares. So this is just a quadratic equation. What's the graph of a quadratic equation look like? Ah, good. It's going to be a parabola, isn't it? Right? And this one, because a is negative, it's opening down, right? So if I were to graph this thing, the graph would just look like, here's h, here's t, so, and it's just doing something like that, isn't it? Right? It's getting, the height is getting bigger with time. Okay? So this is when it starts, and that's probably when it ends. We can check it and see.
Interruption. I have some bus changes I need to let you know about. Students, if you write Eagle, you're going to write Eagle today, but you need to be outside as soon as the bell rings. The bus will be waiting. Again, if you write Eagle, please hustle out. The bus will be waiting for you. Also, Gemini writers, today you're going to ride Ringo. If you ride Gemini to the South Hills, you're going to ride Ringo. Sherwood and Mackay students, you're going to ride Sully. Again, Gemini students on the South Hill, ride Ringo. Sherwood and Mackay students, ride Sully.
Okay, so look what happens. If I plug in 12 and I do all the math, I get 0 as a result. So I put in a 12 and I got a 0. So yeah, that's true, isn't it? The height of the rocket is 0. That's the output when the input is 12. And then finally, let's look at these last two because they're quick. Is h of 0 equal to 40? No. If I plug 0 in for t, what do I get? 0. H of 0 is 0, not 40. So that's not true. The rocket reaches a height of 360 feet. Well, I could easily, where would the rocket be at its, what time would give us maximum height?
6.
6, because it's halfway between 0 and 12. So I could, for this one, I could just do h of 6. And if I do all that, I promise you I'm going to get 180. But we could have just looked up here at our domain right away and disqualified that one. What's the maximum height based on the range that the rocket could ever have? 180, right? And so because those don't match up, here's our range. No, right? Good, good? All right, good job.